Hello everyone, my name is Rajavan Mane. Today I am here to presenting ISE activity 1 of HMT, Heat and Mass Transfer. So my activity name is Design and Composite Wall Facilities of Cold Storage. So problem statement. So what is the problem statement? Problem statement: optimizing cold storage wall. Objectives of the system: optimizing composite insulating wall, minimize the refrigeration load. To minimize the refrigeration load of storage, their operating conductors. Internal temperature is minus 20 degree and external temperature is 35. So delta T is difference between the internal temperature and external temperature. That is 55 degrees Celsius. Conclusion: total wall thickness has fixed at 0.25 0.20 meter is 20 centimeter. Structure: construct outer and insulation middle and FRP inner. So that will outer will be constructed at control and insulation at middle. Design parameters from my roll number. So my roll number is 23. So we take AB is equal to 23. Calculation coefficient outside the convention is 12 kilowatts and inside convention is 25 kilowatts. Geometry: surface area we take 6.2 meter square and insulation of thickness slide is total is 10 centimeter. So polyethylene foam is 6 centimeter and expected polystress is 4 centimeter. So composite wall layer by layer. So we take polythermal insulation is made up of polythene from which ride closed cell from material with very low thermal conductivity, and it provide external thermal insulation. It will be provide external thermal conduction and ride of closed materials low thermal conductivity, and energy of coefficient polyethylene insulation, widely refrigerated system, cold storage rooms, HEV duty tanks, building roofs and walls, conductivity good, moisture resistant. We will be have good moisture resistant and compression strength, making suitable for both resistant and both applications. So extended polythermals XRP insulation is made up of polystyrene through an extruder process, forming a right closed cell from a high moisture resistant, good composite strength and stable thermal performance. XRP is commonly building from wall, roof, or storage. It can be areas exported, dam conductivity and very little water maintains insulating property over time. So that will be diagram of 35 degrees Celsius. Inner walls are outer layer, middle layer part 2, and there is 3 parts of middle layer, and inner layer have FRP coating of 5 centimeter, and outer layer of 5 centimeter, and middle layer part 1 part 2 having 3 centimeter, and inside temperature -2. So it will be protect from it will be cold at that time, and this is the surrounding temperature of 35 degrees Celsius. That will be cold hours. They will be not transfer the heat from outside. So total resistance network we can calculate R is equal to N. Conductivity R is equal to 1 HA convection. So we take R convection, R creation, or polymer foam, R excluded and R convection, and total of them we can add it from that equation. So we take R convection is equal to 1 upon 12 into 6.20. We take already 0.031. That's will be answer. And construction is 0.083, and R from the foam is 0.83 Kelvin and 0.35 into 6.20 is equal to 0.010. So heat load outcome, total refrigeration load Q is equal to dt RTH 55 upon 0.63. That will be taken from here, and 84.32 watt, and heat gain per unit area. So per unit area heat gain is 13.66 watt per meter. So dominance and sensitivity, presentation of calibration, polymer instrumental polyethylene foam, extruded foam, controlling resistance, the FUV insulating layer controlling resistance physically. It means layer provided the greatness barrier to heat flow. The due to accelerated low thermal conductivity, sensitivity analysis, 50% increase in kilowatt. So polyurethane foam, it will be having 0.028 kilowatt and excluded from having 0.04025. So new heat gain is Q new is equal to 13.97 increase in load. Cost analysis and conclusion. So cost analysis based on meter per data for 10 mm thickness for polythene foam la 180 meter per square and extended for the 100 meter per square. So total insulation cost is 280 meter per square. Conclusion: design successful minimize heat to gain 30.66 within the 20 centimeter thickness limit. Thank you.